Okay, so here we're going to look at the standard form of the parabola here, but in this case we have the vertex to not be the origin. Okay, so we'll take a look first here at the parabolas that open left or right. Now notice that, again, similar to our other conic sections, right, the excuse me, the shape doesn't change when we move the vertex, right? But what guides the shape changing is the value of p, right? So we still have symmetry, but now the symmetry is no longer, right, one of our axes, right? So in this case, it's this horizontal line, right? So if the vertex is hk, right, the axis of symmetry is this horizontal line, y equals k, right? Y being, because it's horizontal, and then k, the value of whatever the y coordinate of the vertex is. Right. Now it still has the same pieces that we're going to try to identify. Some focus here, right? And again, the distance here is the same. It's c, right? Excuse me, p in this case, right? C was for our other conic sections. But the value p is taken from the coordinate k, right? So this coordinate would be, excuse me, h plus p, and then k. Let's see. Okay, so we're starting here at the vertex hk, and we're moving horizontally p units, right? And again, if it's opening to the right, this corresponds to a value of p greater than 0. All right, and then our directrix would be here, right? And again, vertical line that moves from our vertex back horizontally p units, so this would be h minus p is equal to x. All right. And then the last piece of information that we'll be looking for are those endpoints of our lattice rectum here. Right? And so the points of our lattice rectum. So in this case, the x-coordinate remains the same. And now the coordinate is still 2p, right? Right, but it'll be k plus 2p. Notice here we're going to be dropping the absolute value here, and here h plus p for the same coordinate, but over here k minus 2p. All right, and here the absolute value no longer needed, right? We're dealing with the with our distances here, so uh, it'll have those coordinates. All right, and when it opens, and since p is already positive, so we don't worry about the absolute value. When it's negative, that's when we'll introduce back the absolute value. Okay, so here for the one that opens in the other direction, to the left. Right, so here this corresponds with p less than 0. So it still has an axis of symmetry. In this case, it's this horizontal line. Still y equals to k. All right. So now the directrix be to the right of the vertex. All right. So the same y is equal to excuse me. It's a vertical line, so it'll be x equal to h minus p. Right. And then our focus would be somewhere here. And the coordinates here would be h plus p. It's still the same k value. All right. And again, remember, p is less than 0, so that plus would be essentially subtracting a value. All right, and then the endpoint of our lattice rectum would be these points here. All right, so in this case, h plus p, right, the x remains the same, and here we'll have k minus the absolute value of 2p, and up here, h plus p, k plus the absolute value of 2p. All right. Okay, and then those are the points for endpoints of the lattice rectum, and then the other information for our parabola that opens left or right. Now, for the parabola opening up or down, okay, so here we'll have the standard form here, x minus h squared 4p times the value y minus k. Right, so we're shifting around our vertex, right, and in this case, for p greater than 0, right, it opens upwards here, and now the axis of symmetry is a vertical line. Okay, so in this case, the vertical line is x equals to h. All right, and the directrix would be below the vertex in this case. All right, and that'll be the horizontal line, so it'll be y equals to k minus p, right? So here, k, and then this distance p, right? And then the focus would be up here. Again, coordinate h remains the same for the x value, and here we'll have k plus p. All right, so that'll be the focus. All right, and then the last piece of information would be, well, the endpoints of our lattice rectum. Okay, so in this case, along the horizontal, right, it's still k plus p, but then here the x coordinate would be h plus 2p, and then on the other side, h minus 2p, comma, k plus p. All right, since it is a horizontal line. All right. Okay, so for the case when p is less than 0, all right, so we get a parabola opening downward. Okay. Okay, so for parabola opening downward, right, at a vertex hk, so the axis of symmetry is still that line x equals to h. Right, and then here the directrix is the horizontal line above the vertex. That will have equation y equals to k minus p, right? Same as before. Here, the only thing here, p would be a negative value, and it'll be above the vertex instead of below for the previous one. Our focus will be somewhere here, right, with coordinates, right, k plus p. The x coordinate remains the same. Our y coordinate would be k plus p. And then the lattice rectum, again, here being the endpoints of this horizontal. Right, so it'll have the same y coordinate, k plus p. The x coordinate here would be h minus absolute value of 2p for the one on the left. And for the one on the right, we have h plus the absolute value of 2p, comma k plus p. Okay, and these are all the values of the parabola, right, that we'll be looking for now. So what's going to dictate again the shape of it would be the p, right? Whether it's positive or negative, right? Depends on which direction it'll open up, and how large or small will depend on the narrow. Will tell us how narrow or wide this parabola is. All right, thank you.